Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Engineers in Progress 4.8. In this video, let's have the challenging problems on fractions. Now, if you want to answer the problems, there are only two. Then you may pause the video and start answering the problems and verify later if the final answers match with the provided answers here. But for those who just want to watch the video and follow the solutions, then you may also do so. So for this fraction, the first fraction, the denominator can be factored by trial and error, and it is equal to x plus 2y and x minus 3y, so that the uh, middle term of the denominator would be negative xy. Then this denominator for the second fraction is sum of two cubes, x cubed plus quantity 2y cubed. The factors are x plus 2y times quantity x squared minus 2xy plus 4y squared. Then for this last fraction, the common factor is 2, so we factor out 2. Then we'll have x squared minus 2xy plus 4y squared, in which we cannot factor that anymore. So again, we have equals 3 over x plus 2y, then x minus 3y. Then we have plus x plus 3y over quantity x plus 2y times quantity x squared minus 2xy plus 4y squared. Square of the first minus the product, then square of 2y, so 4y squared. Then minus quantity x minus 2y over 2 quantity x squared minus 2xy plus 4y squared. So from here, we see that the LCD is 2 times x plus 2y, x minus 3y, and x squared minus 2xy plus 4y squared. So let's put the LCD first. 2 quantity x plus 2y, x minus 3y, and quantity x squared minus 2xy plus 4y squared. So that LCD divided by the denominator of the first fraction, which is this. So it is equal to 3 times 2 quantity x squared minus 2xy plus 4y squared. Then plus x plus 3y, LCD divided by this denominator here, which is this. So it is quantity x plus 3y times 2 times x minus 3y. So x plus 3y times 2 times x minus 3y. Then minus quantity x minus 2y, LCD divided by this denominator would be x plus 2y, x minus 3y. So minus quantity x minus 2y times quantity x plus 2y, x minus 3y. So this is 6x squared, so equals, let's copy the denominator, LCD. Then let's expand. 6x squared minus 6xy, 12xy rather, plus 6 times 4, 24y squared. This is 2 times, since this is x plus 3y, x minus 3y, so 2 times quantity difference of 2 squares, so 2 times quantity x square minus 9y square, so 2 times quantity x square minus 9y square, then x minus 2y, x plus 2y, let's simplify first before we expand. Difference of 2 squares again, so minus quantity x square minus 4y square times x minus 3y. So let's have the product first. Then we distribute on the next, copy the common denominator or the LCD. And let's simplify. So let's copy this first 3 terms first, then expand for this next. So 6x squared minus 12xy plus 24y squared plus 2x squared minus 18y squared. Then minus x cubed plus x squared times negative 3y is negative 3x squared y times negative, so positive 3x squared y. Negative 4y squared times x is negative 4xy squared times negative, so positive 4xy squared, which is this. Then negative 4y squared times negative 3y is positive 12y cubed, then times negative, so negative 12y cubed. Combining like terms, 6x squared plus 2x squared is 8x squared. So copy the denominator this time. We note that x plus 2y times x squared minus 2xy plus 4y square is, let's put it back to x cubed plus 8y cubed, which is this, and this product here. So then times 2. So let's make the denominator back to 2 times, this is x cubed plus 8y cubed, then times x minus 3y, which is this. So 8x squared, negative 12xy, then 24y squared minus 18y squared is 6y squared. Then this is already repeated. Then minus 12y cubed plus 3x squared y plus 4xy squared, then minus x cubed. So actually this is the final answer. Let's just highlight it. So 8x squared minus 12xy plus 6y squared minus 12y cubed plus 3x squared y plus 4xy squared minus x cubed all over 2 quantity x cubed plus 8y cubed, then close, then x minus 3y. So that's it for this first problem. I hope that those who paused the video and attempted to answer this problem have the same answers. So as long as the terms in the numerator are the same, then they are not just in the same manner arranged in order as this, it's still correct as long as the terms are exactly the same. So let's proceed to the next one. This is supposedly a star problem. Then if you notice, the denominator of the first is a to the fourth plus a squared u squared plus u to the fourth. The first, second, and third terms are perfect squares. So if we obtain the square root of the first, a to the fourth square root is a squared. This is the square root of u to the fourth is u squared. And twice the product of the square roots of a to the fourth and u to the fourth is supposedly 2a squared u squared. This lacks a squared u squared to make it 2u squared u squared, so that this three terms will become a perfect square trinomial. But the missing term is also a perfect square. So therefore, to make this factorable, we add a square u square and subtract the same a square u square. So let's transform this into a to the fourth plus 2a squared u squared plus u to the fourth, then minus a squared u squared, so that we can factor this denominator. In the denominator of the second fraction here, the common factor is a. So again, we transform this into a to the fourth plus 2a squared u squared plus u to the fourth, then minus a squared u squared. So equals quantity 3a plus u squared over a to the fourth plus 2a squared u squared plus u to the fourth, then minus a squared u squared. So it is a technique in factoring that needs experience, especially in completing the square, so that it will become difference of two squares. Then minus quantity a minus u over a quantity a squared plus au plus u squared. And we cannot factor this anymore. So this is quantity a squared plus u squared quantity square, then minus au quantity square. So equals 3a plus u square over quantity a square plus u square quantity square minus au square, then minus quantity a minus u over a quantity a square plus au plus u square. So now we factor this as difference of two squares first before we obtain the LCD. So this is written further into quantity 3a plus u square all over a square plus au plus u square, then a square minus au plus u square. So supposedly a square plus u square plus a square plus u square plus au, I just put the au as the middle term of this factor. And the other factor is a square plus u square minus au, which is a square plus u square minus au. So it's the same. Or the square root of this, which is a square plus u square, plus the square root of this, which is this. Then the other factor is the square root of this term here, which is a square plus u square, minus the square root of this, which is that. Then minus quantity a minus u over a quantity a square plus au plus u square. Then we can now see the LCD. It is a times a square plus au plus u square and a square minus au plus u square. So let's put the LCD first. A quantity a square plus au plus u square, then a square minus au plus u square. So LCD divided by the denominator of the first term is equal to a. So we have quantity 3a plus u squared times a. Then minus quantity a minus u, LCD divided by this denominator here is a squared plus au plus u squared. So minus quantity a minus u times a squared plus au plus u squared. Sorry, a squared plus au plus minus au plus u squared, because this is supposedly plus. So expanding, let's copy the LCD first. So a quantity a square plus au plus u square times a square minus au plus u square. Then we'll have 3a square plus au square. Then minus a cube, a positive a cube times negative, so minus a cube. Then a times negative au is negative a square u times negative, so positive a square u. Then a times u square is au square times negative, so negative au square. Then negative a square u times negative, so positive a square u. Then negative u times negative au is positive au square. Then times negative, so negative au square. And finally, negative u times u square is negative u cube times negative, so positive u cube. So we have here, we can cancel au square and negative au square. Then we can combine a square u and a square u. So finally, we have the final answer would be 3a square minus a cube plus 2a square u minus au square plus u cube all over a quantity a square plus au plus u square times quantity a square minus au plus u square. So that's it, and I hope that those who attempted to solve this problem but pausing the video will have the same answers here. So again, it doesn't matter how the terms in the numerator are arranged as long as the terms are exactly the same. And of course, you have the same denominator. So that's it for this video. I hope that you increase your knowledge on simplifying fractions, combining fractions. And I hope that you will little by little become better engineering student.